MA Philosophy, MAPY-001, block number 1, unit number 4, validity, invalidity, and list of valid syllogism. Objectives. This unit brings out the most important part of your study of categorical syllogism. You will be introduced to the rules which determine the validity of arguments. While this is the most important objective, the icing of the cake is the variety of the methods of determining the validity of arguments. Both traditional and modern methods of testing the validity receive due recognition in this unit. Therefore, contribution of both John Venn and George Boole find place in this unit. This particular study enables you to grasp the relation between logic and set theory, which is brought to the fore in this unit. Introduction. In the second and third units, we learned two important aspects of categorical syllogism, with figures and moods. However, we did not develop the technique of distinguishing valid from invalid arguments. Consequently, we could not know under what condition a mood becomes valid, and what is still worse, we could not understand why a certain arrangement or configuration of propositions in one figure is legitimate. Only a legitimate combination of propositions yield a valid mood, and in some other figure illegitimate yielding only invalid moods, and conversely, why a certain configuration of propositions is illegitimate in some figures and legitimate in some other figures. In other words, the question what makes an argument valid was not raised at all. The point is that the validity of an argument depends on whether or not the conclusion is a conclusion in the strict sense of the word, whether or not it logically follows from the premises. This brings us to the vital aspect of our study. Just as application or non-application of rules make a game legitimate or illegitimate, mere application or non-application of rules makes an argument valid or invalid. Application of rules demand knowledge of rules. Therefore, we must focus on the question what rules are there which determine the validity of syllogism. The rules of categorical syllogism. Classical logic list either classical logic lists 8 rules of valid categorical syllogism. 4 of them concern the terms, and 4 of them concerns the propositions. These rules are not probable. They have to be either accepted or rejected. If they are rejected, syllogism is not possible. Therefore, what is given is only an explication of the rules. Classical logic classified these rules under rules of structure, rules of distribution of terms, rules of quality, and rules of quantity. Number one, rules of structure. Number one, syllogism must contain 3 and only 3 propositions. Syllogism is defined as a kind of mediate inference consisting of 2 premises which together determine the truth of the conclusion. The definition shows that if the number of propositions is more than 2, then it ceases to be syllogism. Therefore, by definition, syllogism must consist of two premises and 1 conclusion. Therefore, together they make up for 3 propositions. Number 2, syllogism must consist of 3 terms only. A proposition consists of 2 terms. However, 3 propositions consist of only 3 terms because each term occurs twice. Suppose that there are 4 terms, then there is no middle term, a term common or 2 premises. In such a case, the violation of rule results in a fallacy called fallacy of 4 terms. Such a fallacy is never committed knowingly, because knowing fully well the fixed number of terms, we do not choose 4 terms, but we do it unknowingly. It happens when an ambiguous word is used in 2 different senses or on 2 different occasions. Then there are really 4 terms, not three terms. If an ambiguous word takes the place of middle term, then the fallacy committed is known as fallacy of ambiguous middle. Similarly, if an ambiguous term takes the place of the major or the minor term, then the fallacy of ambiguous major or ambiguous minor, as the case may be, is committed. And the following argument illustrates the fallacy of ambiguous middle. Fallacy of ambiguous middle. Number one, all charged particles are electrons. Atmosphere is the in the college is charged. So atmosphere in the college is an electron. The word in italics is ambiguous. The other two fallacies are hardly committed. Therefore, there is no need to consider example for them. The moral is that all sentences in arguments must be unambiguous. This is possible only when all terms are unambiguous in the given argument. We must also consider the inversion of ambiguous middle. Suppose the synonyms word are used in place of middle term. Then apparently there are four terms, but in reality there are three terms. For example, starry, world, and stellar world are not two terms. Such uses also are uncommon. Hence, they deserve to be neglected. Hence, they deserve to be neglected. Second, rules of distribution of terms. Number one, middle term must be distributed at at least once in premises. If this rule is violated, then the argument commits the fallacy of undistributed middle. One example will illustrate this rule. Second, all circles are geometrical figures. All squares are geometrical figures. So all circles are squares. Second, in the conclusion, no term may be taken in a more extensive sense than in the premises. It also means that a term which is distributed in the conclusion must remain distributed in the respective premise. This rule can be stated this way also. A term which is undistributed in the premise must remain undistributed in the conclusion. However, it is not necessary that a term which is distributed in the premise must be distributed in the conclusion. Suppose that the major term violates this rule, then the argument commits the fallacy of illicit major. When the minor term violates the rule, fallacy illicit minor is committed. The following arguments illustrate these fallacies. 3. All philosophers are thinkers. No ordinary men are philosophers. So, no ordinary men are thinkers. 4. All, all aquatic creatures are fish. All aquatic creatures swim. So, all those who swim are fish. First argument illustrates the fallacy of undistributed middle. Second illustrates the fallacy of illicit major. And the third illustrates the fallacy of illicit minor. Third, rules of quantity. Number one, from two negative premises, no conclusion can be drawn. It only means that at least one premise must be affirmative. Second, if both premises are affirmative, the conclusion cannot be negative. Negatively, it only means that a negative conclusion is possible only when one premise is negative. Number four, rules of quantity. If both premises are particular, no conclusion can be drawn, or the conclusion must always follow the weaker part. Here, weaker part is particular. This rule shows that at least one premise must be universal. If one premise is particular, then the conclusion must be particular only. It means that universal conclusion is possible only when one premises are universal. In practice, last three sets of rule play an important role in determining the validity of categorical syllogism. Uh, Special applications of the general rules. If the previous unit we learned that a certain arrangement of categorical propositions is legitimate in the figure and illegitimate in some other figure, the only exception being EIO. For the purpose of contrast, we should recognize that is reversal. IEO is invalid in all the figures. One way of recognizing valid or invalid arguments is the use of rules listed above. We have another method known as special rules of figures. These rules are called special rules because they apply to only that particular figure but not to others. These rules are dependent upon general rules. Therefore, it is possible to give proofs to these rules. One figures A the minor must be affirmative. B the major must be universal. M P S M so S P A if the minor is negative, then the conclusion must be negative. In negative conclusion, P is distributed while it is undistributed in the major premise. This goes against the rule which asserts that a term undistributed in the premise should remain undistributed in the conclusion. Therefore, minor must be affirmative. B that the measure must be universal is clear from the fact that if the minor is affirmative, M is in it is undistributed, and therefore the measure must be universal if M must be distributed in it. Now we shall apply these special rules to know how or why a certain mood is valid and certain other moods invalid in a figure. A point which we discussed in the previous unit. Let us omit weekend mood. The valid mood of one figure are listed below. Figure number 1, AAA Barbara, EAE Celerant, AII DARIA, EIO FERIO. Second, second A, one premise must be negative. Number B, a major must be universal. PMSMSP. One premise must be negative, otherwise M remains undistributed in both the premise. B, the major must be universal because P is distributed in negative conclusion and hence it must be distributed in the major. The valid mode of second figure are listed below. EAE say CESARE, AEE CAMESTRES, EIO FESTINO Festino, AOO BARO Boroko. Second figure, the minor must be affirmative. Number B, the conclusion must be particular. MPMSSP. A minor must be affirmative because negative minor gives only negative conclusion, in which case P is distributed in the conclusion. P can be distributed in major only if it is negative. Negative minor results in negative major, which is not allowed. Therefore, minor must be affirmative. B, the conclusion must be particular, otherwise S becomes distributed in the conclusion while it remains undistributed in affirmative minor. The valid mode are listed below. Number 3, AAI DARA Tarapti, DARAPTI, IAI DISAMIS, AII DATISI, OAO BOCARDO, EIO FERISON, EAO FELOPTION. Number 4 figure. If the measure is affirmative and minor must be universal. B, if the minor is affirmative, the conclusion must be particular. C, if the conclusion is negative, the measure must be negative. P, M, MS, SP. The valid mode are listed below. AAI DARA Darapti, AEE CMENES, EAO FESAPO, IAI DIMARIS, EIO FRESISON. It would be good logical exercise for the student to take up these special rules and try to deduce them from the general ones. This is the reason why we have left the special rule of figure 4 unexplained. Reduction of argument to one figure. Reducing arguments from one figure to the first figure is one of the techniques developed by Aristotle and one of his followers to test the validity of argument. after reduction. If the argument is valid in the first figure, then it means that the original argument in the corresponding figure is valid. This technique is quite mechanical, so we are only required to know what exactly is involved in this method. We will learn this only by practice. Strengthened moods are included for the sake of exercise, though they are not required from the point of view of modern logic. There is no need to consider weakened moods separately when the techniques involve this reduction. What is required is replacement of universal by its corresponding subaltern in the conclusion. Number one figure. Uh, Figure number one, CELARENT. Figure number two, CESARE. Conversion, PEM conversion, MEP, SAM conversion, SAM, SEP conversion, SEP. No politicians are poet. Conversion, no poets are politician. All girls are poets. All girls are poets. So no girls are politicians. Uh, so no girls are politicians. In CESARE, S after E indicates simple conversion. It shows that E major premise must undergo simple conversion. Second figure, second figure, CAMESTRES. Figure number one, CELARENT. PAMMES. CEM conversion, MES. PAM conversion, ME, PAM. So SEP. So PES conversion, SEP. S and T after E shows that E minor premise should undergo simple conversion and both premises be transposed. S after second E shows that in this E conclusion also should undergo simple conversion. The student is advised to construct argument for this and subsequent reductions. Number three, figure number two. Figure number one, FERIO. Figure number two, FESTINO. PEM conversion, MEP. SIM, SIM. SOP, SOP. FESTINO becomes FERIO when the major premise undergoes simple conversion. The kind of reduction to above mentioned mood is known as direct reduction. BAROCO becomes FERIO through the process of indirect reduction. Indirect reduction include, in addition to conversion, obversion also. Number four. Second figure, BAROCO. Figure number one, FERIO. PAM obversion, PEM conversion, MEP. SOM obversion, SIM, SOP. Number five, third figure, DARAPTI. Figure number one, DARII. MAS conversion, SIP is equal to SIP. 6, DATISI. DARII. MIS, SIP. 7, FELAPTION, FERIO, MEP, MAS conversion, SIM, SOP, P, which follows A in DARAPTI and FELAPTON shows that conversion by limitation applies to A. 8 number, FERISON, FERIO, MEP, MIS, SIM, SOP. 9, DISA, DARII, MIP, MAS, PIM, PIS, conversion, SIP, which the reduction of the above mentioned mode is direct. Next one is indirect. Number 10, BOCARDO, MOP, observation, MIP, conversion, PIM, MAS, SOP, PIS, SIP, SOP. When BOCARDO undergoes reduction, conversion, obversion, and transposition are required to complete the process. Here, OAO becomes AII. Further, when we consider overted conclusion of all, we obtain AIO. This is surely a paradox. Second, fourth figure, one figure, BRAMANTIP, weekend mood, PAM equal to PAM MAS, MAS SIP PAS conversion SIP, 12 SEMENES, CELARENT, PAM MES SEP, 13 DIMARIS, PIM MAS PIM SIP, 14 FESAPO, PEM conversion MEP, MAS conversion SIM, SOP. As usual, S stands for simple conversion of E major premise and P stands for conversion by limitation of A minor premise. This process is similar to the one applied or when applied for first and third mode of third figure. 15 FRESISON, FERIO, PEM conversion MEP, MIS conversion SIM, SOP. From reduction technique, one point becomes clear. Originally, there were 24 valid modes. Later, weakened and strengthened modes were eliminated on the ground that particular proposition, existential quantifier, cannot be deduced from universal propositions. Universal quantifier universal quantifier only, and the number was reduced to 15. Now, after reduction to first figure, the number came down to 4. Strassen argues that reduction technique is superior to axiomatic techniques to which he referred in the beginning of his work, Introduction to Logical Theory. He regards the mood as the inference pattern. He argues that the path of reduction should be an inverted pyramid. Strassen also maintains that in addition to equivalence relation, we require opposition relation also to effect reduction. What we gain in the process is economy in the number of moods and anti-logism or inconsistent triad. This technique was developed by one lady by name Christian Lad Franklin. This technique applies only to 15 moods. The reason is again impropriety of delivering existential from universals only. The method is very simple. Consider when results from all propositions replace the conclusion by its contradiction. This arrangement constitutes an antilogism. If the corresponding arguments should be valid, then antilogism should conform to certain structure. It must possess two equations and one inequations. A term must be common to equations. It should be positive in one equation and negative in another. Remaining two terms ought to appear only in equation. Consider one example for a valid argument. All Indians are Asians. Whence result antilogism. All Indians are Asians. IA is equal to theta. IA is equal to theta. All Hindus are Indians. HI is equal to theta. HI is equal to theta. So all Hindus are Asians. In this case, antilogism satisfies all the requirement. I is common to equations. In one equation, it is positive and in another negative. There is only one inequation. Remaining term appear in inequation. In all cases, this is the method to be followed. If any one of these characteristics is absent in antilogism, then the corresponding mood is invalid. Now, antilogism can be easily constructed for the remaining 14 moods. This This can be seen in figures only, so there is no possible to audio it. There is no inequation in this anti-logism. Hence, corresponding argument is invalid. It can be shown that any other strengthened or weakened mood is invalid. Venn diagram technique. Let us extend our knowledge of Venn diagram of the testing of arguments. If two terms yield four products classes, then three terms should yield eight product classes according to the formula 2 star n, where x stands for the number of terms and n stands for the number of product classes. Since syllogism consists of three terms, we have eight product classes. Let us begin with a valid mood and list these product classes. PAR P1 all MRP, P2 all SRM, Q all SRP. MP is equal to theta, SM is equal to theta, SP is equal to theta. The product classes are as follows: SMP, 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 SMP. While listing product classes, sufficient care should be taken to ensure that no product class is repeated. It is always advisable to make a list of product classes with diagrams and mark classes accurately to avoid confusion. Now let us use diagram to represent the proposition. The procedure is as follows: null sets are shaded and non-null sets are starred. We should also note that product of null set and non-null set is a null set. It is like saying that 4x0 is equal to 0, but the union addition of a non-null set and non-null null set is a non-null set. Remember, 4 plus 0 is equal to 4. Since MP dash is a null set, not only SMP dash but also S dash M dash P is a MP dash is a null set. It does not mean that there are two null set. There is only one null set. SM dash is also a null set. Therefore, not only the product of SM and P, but also SM and P is a null set. Now we shall shade relevant subsets which are null. P1 and P2 shows that S dash M P dash is equal to SMP dash and SMP dash and is equal to SM dash P is equal to theta. The conclusion shows that SP dash is also is a null set. We did not especially shade SP dash. Shading of MP dash and SM dash included naturally the shading of SP dash segment. This is what actually happens in the case of valid arguments. Marketing Marking of premises naturally includes the conclusion. It is not marked separately. In other words, marking of conclusion is inclusive. When we adopt Venn diagram technique, this important condition should be borne in mind. Secondly, when any premise is particular, the segment which corresponds to the universal premise should be shaded first. This is the initial step to be followed. Now we shall consider some moods. Others are left for the students as an exercise. In all cases, all product classes should be identified by a student even if there is no need. There is a good exercise. This is a good exercise. Number two, BAROCU. All PRM PM dash is equal to theta. P2 some S are not M. PM dash is not equal to theta. So Q some S are not P. S P dash is not equal to theta. In this case also no information is available on SM dash P and SMP after the premises are diagrammed. Here AAI is invalid. Boolean analysis. George Boole published his work, The Mathemat- Mathematical Analysis of Logic in 1847. This work provided not only the required breakthrough to logic but also a new direction to its development. This analysis is known as the Boolean algebra of classes. It is a rewarding exercise to understand this approach. Boolean analysis presupposes some axioms. Basson and O'Connor list 13 axioms, while Alexander considers 7. However, for our purpose, only 4 of them are sufficient to understand this analysis. Let us begin with these axioms. Number 1, law of multiplication. A, a, the product of a universal set and a null and a non-null set. S is a non-null set. B, the product of null set and a non-null set is null set. 1xs is equal to yes when one is the universal set 1a. Theta is equal to yes is equal to theta 1b. Second law of addition. The addition of complementary sets is universal set. S plus s dash is equal to 1 2. 3 law of commutation for a addition and b multiplication. Transpo transposition of two or more than two set is equivalent to original structure. A s plus p plus m is equal to s plus m plus p is equal to p plus m plus s is equal to m plus s plus p is equal to 3a. B s p m is equal to s m p is equal to m s p is equal to m v s. 3b. Instead of addition and multiplication, we can also use union and product respectively. Number 4, law of distribution. The multiplication of a one set on the one hand and the addition of two non-null set on the other is equivalent to the addition to the product of two sets. SP plus M is equal to SP plus PM. 4. Some valid modes are worked out and the rest are left as exercise for the students. Number 1. BAR Barbara. P1, all men are P. M P dash is equal to theta. P2, all S are M. S N dash is equal to theta. Q. So all S are P. S P dash is equal to theta. Boolean analysis begins with the expansion of statements. The first stage of the expansion of major premise is as follows: MP dash is equal to MP into 1. Rule 1b is equal to MP dash कोष्टक S plus S dash is equal to MP dash. Rule number 2, MP dash yes plus MP dash yes dash is equal to MP dash. Rule number 4. Now we shall pass on the second stage. A S is equal to MP dash is equal to S MP dash is equal to theta. S is S dash is equal to MP dash is equal to S dash MP dash is equal to theta. Rule number 1. MP dash is equal to SMP plus S dash MP dash is equal to theta. The last line corresponds to the expansion of major premise. While expanding these lines, we must obtain the addition and union of the product of all relevant sets and their complements as well. On these lines, we shall expand remaining lines. B is equal to P is equal to SM dash is equal to P SM dash is equal to theta. P multiply S dash P multiply S M dash is equal to P dash S M dash is equal to theta. Rule 1v. P S M is equal to S M dash P is equal to theta. P dash S M dash and S M P dash is equal to theta. Rule number 3b. Sm dash is equal to Sm dash P plus Smp dash is equal to theta. The last line corresponds to the expansion of minor premises. Sp dash multiply m is equal to Sp dash m is equal to theta. Sp dash multiply m dash is equal to Spm dash is equal to theta. Rule 1b. Sp dash m is equal to Smp dash is equal to theta. Spm dash is equal to Smp dash is equal to theta. Rule number 3b. Sp dash is equal to Smp dash plus Smp dash is equal to theta. A plus B is equal to Smp dash plus S dash M P dash plus Sm dash P plus Smp dash is equal to theta. Since the union of four product classes is null set, any set in this group is null set. Consider the union of relevant sets S M P dash plus Smp dash is equal to theta. Since this is equivalent to what we have obtained from the conclusion, the argument is valid. This shows that the expansion of conclusion must be equal to or less than the union of premises if the argument is valid. Hence, this conclusion is not repeated further while dealing with some arguments which are valid. Since we follow this method throughout, we should bear in our mind all these details. Let us sum up. General rule apply to all figures, whereas special rule apply to special figures. Special rules indirectly depend upon general rules only. Antilogism, Venn diagram technique, and Boolean analysis do away with the concept of distribution of terms. According to the last three methods, weakened and strengthened methods becomes invalid, though traditional logic regards them as valid. Keywords. Mood. By the mood of the syllogism is meant the kind of a syllogism which is determined by the quantity and quality of the three propositions. Figure. By the figure of the syllogism is meant that the kind of syllogism which is determined by the function of middle term placed in the syllogism. Thank you.